All right. Hello, everyone. Thanks for having me here. So just a kind of quick getting to know you a little bit. Who are you here are developers? Okay, we got a room of developers. That's great. Because I think my talk will be more related to developers who is developing Kafka-related applications. And who today is thinking about AI right now? Everybody, right? Me, at least. Have you used ChatGPT or Copilot right now? Well, I did. I love it, by the way, because I use it to write my comments because I'm terrible at writing comments. So I just ask Copilot, like, write my code and ask it to write my comments. I have a very nice commented applications, but these are just something that we're thinking about today. So perfect. Let's go ahead and go through. So a little bit about me. I used to be writing a lot of Java applications, but then I got into Kubernetes and Camel. I don't know if you heard about Camel. So I work in Red Hat for almost 10 years. Now I'm with Redpanda. You'll know about Redpanda a little bit later, but I think the focus of today is about AI, right? You've heard all these buzzwords about AI, but what is AI basically? Well, if you're running today's generative AI applications, what do? You write the applications, and then you add a LLM into your applications, or you call out an API call back to your LLMs. Basically, that's it, right? So your user will then ask questions, you put it into your LLM, do some prompt, and then the LLM processes it, and it gives back to your users. This is basically how you write AI-enabled applications, right? But any one of you who watched the launch of AI Pin like a couple of months ago? It was kind of a disaster, right? Because when he first started talking about it, was awesome. He was like, asking questions about AI pins. It's awesome, it's great. But then, then he started asking these questions. When's the next eclipse, and where is it gonna be? And you know what? It gives a wrong answer on that launch event. What a disaster. That's worst nightmare for us. Like, we do demos every single day. And having that to happen on the launch day, that is like, oh no, like terrible. So you know what? Maybe running an AI built-in application is not as easy, as simple as just calling the LLMs, right? You're gonna bump into a few problems. First of all, performance problem. How many of you who uses ChatGPT and type in your questions and wait 2 minutes for it to come back? Because it takes time, right? It's gonna have performance problem. And thinking about it, writing application that uses ChatGPTs or OpenAI and ask it to provide information back in 2 minutes, and your user is probably gone, right? Performance issues. And then you're gonna have incorrect, unpredictable results, like what you see on OpenAI, like the AI pin disaster, right? And then most of them is text-based, right? A lot of them is text-based. Well, and then I don't know if you notice, I've been running like Llama 3, Llama 2 on my laptop. But every time when I turn it on, like my computer is burning. It's like it's taking a lot of resource, right? So it's using a lot of your hardwares and all that kind of stuff. And it's just a lot of money goes in there. Think about all these models that you're running. It's going to cost you a lot of money. So that's when we think about how do we build our streaming or our AI architecture with streaming. It's going to help it, but how? How is it going to help? So there's a couple of different parts. If you kind of look at AI in 2 different parts, there's going to be a machine learning part where it's generating the models. This is the traditional way of getting your model ready. We've been doing this even before ChatGPT's or OpenAI started. We've been doing a lot of that. So we're just gathering all these data sets, taking a look at these data sets, generating a model. So basically what you do is you put in a lot of data sets. The data scientists predict a data model that they think this is, then kind of figure out kind of features that it needs, feeds into the data models and let it train. And then also test it. Then it will create a model. So what you do is that model goes into a model registry. And then your application will grab that model from model registry and then start processing it, right? So where does streaming comes in, right? Streaming helps you to collect data from these data layers. So we are now collecting a lot of data layers, a lot of data into data layers. Hence, the data object store that we talk about, because there's going to be a lot more data going to be stored. And streaming allows you to capture your data a lot faster, because if you think about traditional batch processes, it takes a long time to process it, right? So in order to get things faster to train your data, this is how streaming will help. It will help you to get your data faster to train your models. And then in terms of the inference part, where the actual application of running that particular model, whether it's models or LLMs, it is going to be ingesting information to your applications, and then also adding some of the reference data into it to make it a little bit better, right? So a better AI implementations comes in two ways. So one of them is making sure that your model is in real time. It gives you, the most accurate information, gives you the most accurate predictions. So that's why you need real-time machine learning. And then you want to have, on the inference side, you want to make sure you're giving the right context to your LLMs, so it would know how to answer back to your user with a certain context without, like, it grabs random information from the internet and provides you information, right? So that is why we have this RAG. I'm pretty sure everybody probably heard about it today, like retrieval augmented generations of, all that. But I mean, and then fighting your LLMs, right? So these are the two things that we do. So let's talk about this RAG. I didn't want to talk about it before this talk, but I did a demo this morning, so I want to show it off. That's why I want to talk about it. So I wrote this demo fresh this morning, so if there's anything goes wrong, sorry. But the way I want to show it is because how to use streams this morning, well, stream, I think in the inference part where you're using the API would be mostly very similar to what event-driven architecture is giving you today, right? So you're gonna get a lot of information inside, and they're all delegated to the broker. The broker then will be ingesting all this information and become that buffer. But what happens is you're gonna have a lot of different applications, different services using different models. And then they all connected to different models, and some of them would use VectorDB to do their RAG, to use embeddings to find the related contents and then send it back to your applications and do your AI stuff. And some of them would just use external information coming from the services outside. Some of them would load documentations and then to feed that into your models to give correct information, right? So then your broker will then spread this information across, well, it will broadcast all these events across different models, different services. And then once they're done with getting the information back, they all get back to your broker, and then you aggregate it. It gives back to your users. So this is more like how streaming can be used in your inference AI architecture, right? So you can kind of spread the work around, scale it, and then also being able to aggregate it better. So how to aggregate it? I think Rising Wave today will give you a good answer for that, right? So correct. So I think there's a lot of things that can be done. So for my demo today, I don't know, how many of you are into RPG games? Like, I'm into RPG games, like old school RPG games, like 8-bit RPG games. And you know what I hate the most about RPG games? Are the NPCs, because they keep looping the same information, like the same thing over and over again. I talk to the NPC, they only give me 3 different answers. That's like boring as hell, right? So I wanted to talk to the NPC, and they will give me different things every single time when I talk to them based on the questions I ask them. So how do I do that? So the way I did it is I created several different NPCs services. Each NPC loads a certain text base. So they all have their own little story. Say, my hero, he just slay a dragon this morning. So he's gonna give me answers about dragons. And my sorcerer, NPC 2, is gonna give me something about her dark secret, right? And I have a goddess who is gonna be like, holy and whatever she does. So, and then they all were connected. So what I did was I wrote this application. So now I'm gonna talk to maybe just the hero. Say, hello. How are you? So what happens is it is going to then go back to my applications. Where did my thing go, right? My Python applications. And it actually sends information into my Llama 2. And that Llama 2 gets, asks the Llama, and then it sends back to my WebSockets, and then WebSockets will then give an answer. It says, amazing, thank you, I just defeated a monster, right? Things like that, you can talk to it. This is a very early stage of my demo. I just want to show you what an AI can do, right? But what happens in here is that I have a, oops, not here. This is what happens in my Redpanda broker. So Redpanda is a drop-in replacement for Kafka, same as Rob Streams, but we did do things a little bit differently. I'll show you a little bit later, but this is our console. So what happens here, I'm receiving an MPC request coming from the MPCs, and it tells me which MPCs, I don't know, this is too small, but it gives me like the answers, who is this MPCs coming from, and ask the questions. And then I have a small application, a WASM application, I'll tell you what it is later, but then it will dedicate this information, this particular questions to my MPC request. And then my application, which is going to be a very simple application that I have written, where is my Ask Hero? So this is a small LangChain application that I wrote, very simple LangChain. So LangChain is like this, this thing where it allows you to interact with your model. So basically what happens is I'm consuming from a Kafka topic, and this Kafka topics will then receive a questions, and then we'll send these questions into a Llama 2, and the Llama 2, it will send to my Llama models, and my LLMs will generate informations, and then it will send back to my Kafka producers, and then it will write back to my Kafka topic, which is going to be the RPG response, and then it's going to say, all right, this is my information back. So this is an event-driven architecture that I wrote, and I have several different services. Now I don't just have the heroes, I have the goddess, I have the sorcerers and all that. So they all represent a different way of how you can interact, how you can prompt engineer, how you can add more different documentations for your AI applications, right? So that is a little quick RAG demo that I did this morning. I hope you enjoyed. I will share the code with you a little bit later. But that is not what I'm here today for. I'm here today to talk about the machine learning, real-time machine learning, right? So we're going to talk about here. So how do we make the machine learning faster, quicker with streams? It's very similar to what we do, but before we dive into how that does, I want to talk to you a little bit about Redpanda. So how many of you who run Kafka today? Right, okay, perfect, great. So you'll know this. How do I set up a Kafka? First of all, I have to install a JVM on my local laptop. That's something that you have to do, Java. And then I have to spin up a broker and a zookeeper, or you're doing a KRaft. Whatever that you're doing, you're gonna do that. And then once you have it, you want to set up your schema registry, because this is the same as API, the contract. We have to do this if you're doing Kafka, because you never know what's going into the topic. So it's better always to kind of give people the data shape of what you have in the topic. So you always want to have your schema registries. Sometimes I will spin up an HTTP proxy, because some of the client doesn't really speak Kafka protocols. So I'll have to expose my Kafka endpoint through HTTP protocol, right? Something that I have to do. Then I can write my clients. My clients then talk to the Kafka brokers. The Kafka brokers receive my data. What happens is it will then go through, it will write data. It will use JVM to store everything in the memories. And once it's full, once it's there, it's going to push everything into page cache. Page cache is a mechanism in Linux that temporarily stores things in cache before it puts things into your disks, right? So this is what happens in Kafka. Normally when you have Kafka, you have this. So what Redpanda is that, you know what? We don't really want you to have JVMs. So let's just get rid of that JVM. No need to install a JVM. And then what do we need that zookeeper for? It's a consensus algorithm. It's just making sure and keeping your brokers, that know their status. These are the states, and the metadata to store the state of your brokers. That's it. So why do we need an extra thing? So in Redpanda, we have our own consensus algorithm, Raft. So even the metadata, all the partitions use ref consensus algorithm to talk to each other and to make sure that everything's up. And then we also think, why do you have to spin up a separate schema registry when you can have it inside the broker? So when you spin up a Redpanda broker, the schema registry is already inside. You don't have to spin it up. And then why do we have to spin up another HTTP proxy when we already have one, when we can have it already in the broker? So Redpanda would already have a HTTP proxy inside the broker. So when you stand it up, it will be there. And why do we need page cache for when we can talk directly to the disk, right? So this is what's going on with Redpanda. So when your client, so the client was because we're using the same Kafka protocol, you don't have to change your client. Your client, you just take whatever with your Kafka and plug it into Redpanda, it will just work. And the best thing is when you write your data into your brokers, it talks directly to your memory. It doesn't go through that virtualization layers of JVM, so you don't have to tune your heap. You don't have to think about all this JVM tuning, all that stuff. It just does it for you. So if you want to learn more about how Redpanda works, because we're written in C++, we use this C* frameworks to efficiently put your data into memory. We have I don't like this thing here. We have this Redpanda YouTube channel. I have done a bunch of videos. Go to Redpanda versus Apache Kafka. I have a bunch of video teaching you how C* works. So I won't dive into that because we want to focus on AI today, right? So once it will write directly to the memories, and it is going to do fsync directly right into your disk. And then once it's in the disk, then it will act back to your producer, the clients that you're talking to, letting them know that, hey, your data is safe. You can now send the next one, or you can now do whatever that you want to do, right? So it is safe, so you're not going to see that loss of data because we don't write into page cache, right? So that is what Redpanda is. And you know what another cool thing that we do is we have this WebAssembly data transform inside Redpanda. So why do we call it WebAssembly? Do you know anybody who heard about WebAssembly? WASM? Cool, awesome. I think you probably know like this is a very cool engine that talks to your browser. But what if this engine doesn't talk to the browser, but it talks to our operating system, right? So we use this engine that you can use the same binary, but it will talk to your operating systems and your machines, right? So so that you can write your logic, deploy that in your brokers, and then do your transformations. This is what we do, right? So if you think about all the pipelines, data pipelines that you're building today, we have a bunch of pipelines. We have stateless pipelines, stateful pipelines, micro batch, and batch pipelines. To be honest with you, I don't think they will ever go away. If people tell you that you're not gonna see batch pipelines, it's wrong. It's gonna be there forever, because there's just gonna be like large amount of data you have to process, right? And I think for WASM, for the type of in-broker pipelines are best for stateless pipelines. For state pipelines, Rising Wave is probably a good answer for you because you can keep the states and all that. But for small in-broker, quick masking, filtering, rerouting, if you want to do something really fast, it is good to use that type of thing. So I'm just kind of telling you where it sits. So why do we want this, right? So if you want to do a transformation today, what do, right? So the data sends into the broker sends into the data pipeline processes it and sends it back to the broker, and then another data pipeline gets it, right? That's how it works. But there's a lot of data ping-ponging, right? It goes through the networks. It goes through your sockets, process it, goes back through your sockets, network layer, and puts it into your memories and your disk. There's a lot of data ping pong around here. So what if we get rid of that data ping pong, right? If we write our data into the broker and do the transformation inside the broker, and then sends it right to the topic next door in the memory next door, isn't it faster, right? It's a much better, much efficient way of doing transformations. So That is why we do this WebAssembly. So we basically have that engine to allow you to use WebAssembly. So basically use your Golang, use your Rust, use your JavaScripts. Currently we support those three, and you can turn these into a WebAssembly binary. You have to build it. And then once you build it, you can use that to do your transformations. So that's how you do it. So what happens, how do you do that? You can use a RPK. So this is a tool that we provide to you. You do an init, it is going to bootstrap that entire folder for you, and then you can write your code. We're gonna see that live later. And once you can deploy that onto brokers, what happens if, once you deploy that onto the broker will then distribute that across all the broker in the same cluster. So every single one of the broker would get a copy of that binary. And then when your data hits the topic, it is going to do the transformations, and that transformation is going to do that. So, and if you take a look, if you see how that works internally, you're going to see that, hey, this is how it works. So if it hits your data, it is going to write into your memory, and the CPU sees that, it was going to read the same cache, transform it, and then put that into another part of the memory. So basically, that's how fast things can work inside that. So that is why I say it's super fast transformations that you do. So let's go back to our a little bit about our implementation. So we're going to do an LLM here. So what we're going to do is we're going to do a real-time data machine learning. So basically what the real-time data machine learning does is first you have a problem, then you have your ETL, then you do your feature engineering, right? Feature engineering is like, making the data sets fits better for your models, right? And then you do your trainings, and then you deploy your models, and you can start the predictions, you see how the model goes, and then you do the whole thing over again. So this is like how your machine learning works. So this is actually a workshop. I invite you, if you have your laptop with you, this URL will get you a workspace. You can actually work with me on getting that ready. It's okay if you don't have your laptop today, because I will keep this workshop open for another week. So whenever you have time this week, I would encourage you to, play around with it, see how that works. So basically what the scenario was, we have a lot of food delivery system, people delivering food, right? So as a person, I'm looking at my app, thinking, how long am I going to get my food? I want to have the most accurate prediction of when I am going to get my food. And so what happens is that, this app will keep getting, raw data from each and every deliveries. So can we enhance our data model to be more accurate depending on, the day of the delivery, kind of predict a better time for my users? Can I do that? This is something that we're going to do, right? So we're going to get that data in and then process the data in broker. I'll let you know why we're going to need that to process that in broker, and then send that into machine learning trainings, and then update the model dynamically, and then push that model back to my application. This is what we're going to do. So first of all, in this environment, this is what you're going to see. You're going to see this is a VM. So basically, you got a VM, you got the instructions on your side. So basically, what we're going to do is we're going to pull down all the things that we have, right? So if you kind of do a git pull, this is all the code that we need. And the first one we're going to take a look at it is the Docker Compose file. So like what I said, starting up Redpanda is pretty easy. It just takes RPK. RPK is the CLI tools that we provide for you, but I prefer to use Docker because that's my preference. So I just put everything in my Docker file. I use Docker file for another reason. It's because I also want to start up the console as well, right? So then I am going to do a Docker Compose up to start my brokers, right? I'm starting my brokers. Now my Docker started. I also started my TensorFlow because I want to show you how everything works. And then I am going to start up my Jupyter notebook, right? So I'm going to go ahead and then go in, sign in. Did I put the wrong password, right? And this is what a data scientist, their day-to-day looks like. They will get the data, they will they will receive a data set, right? And they will run it. Where did my run show go? Here. So what happens is it's going to start loading all the data I'm reading just from a text file, right? So this is the information I'm getting, where the delivery person is, I'm going to get their age, I'm going to get their ratings, I'm going to get where the restaurant, the original place of where I'm getting my food, the latitude and the longitude, and the delivery locations of where I'm going to deliver things. I'm going to get, if this person's getting a food, beverage, or snack, I'm going to see if this person's riding a bike or if this person is using scooters, whatever, and time it takes for them to deliver things. And then I'm going to do a few, look at my data, see how that works. Okay, I'm going to maybe do some calculations. So this is the first step of feature engineering, because I need to calculate the distance based on the latitude and the longitude using some simple geometric. This is when your high school math actually works here. So, learning how the distance works. So just calculate the distance between the food and the delivery destinations. And then the data scientists will then go ahead and take a look at, hey, is this person's age, delivery person's age, is affecting how fast they would deliver the food? Yes, because we see a linear progression going up, right? And then they're gonna take a look at, if the person's rating will be related to when the food gets delivered. And yes, the better the rating, the time it takes is less. So we know that the age of the driver and also the rating of the driver is actually related to how fast you're gonna get your food. And we're gonna take a look at other informations like, the types of vehicle, gonna take a look at, the different things on top of it, but they don't seem to matter. So the three things that actually matters are the age, the rating, and the distance. These are the three things that matters. So we know that we need these to train our data. But if you look at the information we're getting from these devices, right, this is not good. So what happens is now we need to figure out a way to live inject the data. So to do that, what we can do is we can now go ahead and then create a Kafka topic. So I'm going to go ahead and create Kafka topics. And if you go to the Redpanda console that we have, you see I created two topics, the raw topics and the topics that will be to send to the model, to train the models. And then when I do that, I can go ahead and then start producing data into my console, and I can see the raw data coming in, right? So but they don't actually calculate the destination for me. So that's something that I need to work on, the features to work on. So what do? So I need something that quickly can transform on real time for me on the SanDisk, right? So that's where the WASM thing comes in. I can create that in broker calculations as the data comes in. It will calculate the destinations and then send it to train the models. So what I have to do now is I have to turn on the data transformations, because by default it does not turn on. So I need to restart my brokers, similar things. And then once I have it started, I can now start the transformations. So what I need to do is do a quick init, and then RPK, transform init, is going to bootstrap that entire thing for me. So I'm just going to say, yeah, I'm going to write a tiny Go instead of Rust. And I need all the dependencies. And what it does is going to pull down all the dependencies and bootstrap everything for me into that particular folders. So it's going to pull down everything live, and then now I have a folder called SuperPanda. So I'm going to go ahead and go into that SuperPanda, and you can see that it creates that bootstrap content for me. So if I make it a little bit larger, it creates a couple of things I need. It gives me a structure of what my code should look like. So it takes in events, it sends out events. So basically it takes in, and then you can do some transformations and then take it out. So I'm just going to go ahead and then paste my entire geographic transformations, and then also filter the data. So I'm only sending in the age, the rating, and the distance. By the way, all these comments are done by Copilot. I didn't do all the comments. I just asked for it to do it for me. So once I'm done with that, I can then go back to build. So this Golang thing is done. So I need to turn this into a WASM binary. So what do I need to do? I need to do a RPK and then transform build, which is now is taking that Golang and turn that into a binary code, right? So it is going to now start building things. It's going to take a little bit of a time, but if we go back to the console, what happens is now it is going to build it, and then once we finish deploy that into our broker, you're going to see new data coming in. So let's go back and see if that's built. All right, so it's built. We are now going to then deploy that, deploy this binary, put that into the broker. So I'm going to go ahead and then deploy that into the broker. Did you notice that I have an input topic and an output topic? So the input topic says I'm reading from the raw data. The output topic is I'm going to send it to the model data topic. So once it's done, I can see, like I can do RPK. I cannot type today. Transform list. So I can see that now all this transformation has been deployed to all 3 brokers. Awesome. Now I can now send data into my brokers. I can now send into my brokers. Now I'm sending more data into the broker. You can see that, see if the raw data is going in. You can see that's going in. And we can go back to the model data. And now we can see the model data actually doesn't contain a lot. It contains just the age, the rating, and the distance of the deliveries, right? So this is the time when we can go back to our Jupyter notebook and we can take a look at the consumers. This is when we can start. So as a data scientist, I would already be determining what model I want to run. So I'm just going to go ahead and then start the model. So we're going to use a sequential LSTM model. To be honest with you, I have no idea what that is. I'm not the data scientist, but for any of you who knows data sciences, please come and help me and understand this model. But basically, it was more like a linear way of figuring out how things are. So I'm giving it 3 things: destinations, and I'm giving the age and also the rating. Now what this is the meat of this entire talk, which is getting data from Kafka and then sending it directly into my model. So I'm going to go ahead and then run it. It is now going to directly consume data, ingesting data from my model, and it is now going to train it on the go. So as the more data coming in, it is going to now train the data. So it's going to take a couple minutes to start training, but once it started training, I have in my code, I have had it running and generate a model and then put that into a folder. So my inference can consume the same model. So basically that's it. So once it's done, I can then go to my other app. So this is another Jupyter notebook I wrote. Basically what it does is just ask you to input your age, name, and destinations, and it's going to give you the latest predictions. All right, once this is done, I have my model ready. I can go ahead and then spin up my predictions. This is not as pretty. Oh, it's not yet ready yet. So the reason why I think it is because model is not generated yet. It is still processing. So let me do that again. It's not ready yet. So we have to wait for the model. It takes some time to actually get it running. But once it's ready, we can run the. So if you're running the same thing, just be patient. I don't have the patience. Come on. Still running, that's why. So once it stops running, you'll see the model. You can start predictions. And that is how you get a real-time machine learning model. There you go. Okay. Did it start? Yeah. So this is how you get your real-time machine models and predictions later on. So you can now have your driver's age, and you can have its own rating. You can have the destinations and predict. And it's going to tell you, hey, with a driver age of 29 with rating of 4, you're going to get your food. And with your 50 miles radius, you're going to get your food in 30 minutes. So this is how you get your real time. And the more data it comes in, you're going to refresh your model as quick as possible. So this is how we get real-time predictions with streaming. So thank you for coming here today. I really appreciate it. I have some stickers there. If you want to get some stickers, to look at my laptop, you're welcome to. And then these are all free informations. I built all these courses on Redpanda University. So if you want to learn more about, how do I get started with streaming? How do I, start up? How do I do day-to-day operations with Redpanda? I want to learn more about Redpanda. This is all free informations. And the course, and then of course for today's for today's workshop, this is the link. Make sure you take a picture of that. I can share that with you later, but it will be up for a week. You can play around with it, do some machine learning, and let me know what you think about the workshop. All right? Thank you very much. Do we have any questions? Yeah. Am I supposed to answer questions? All right. Cool.
The traffic in Bangladesh.
Predict traffic. I think it's going to be a difficult thing. I predicted to be arrived in an hour, but actually got here an hour and 25 minutes. So
it's not going to happen in 30 minutes. So what I see it right in your models, there's going to be external API which can give me the real metadata information out.
Yes.
Which is like what are the events are happening and what will be the traffic is going to happen. So I can take this metadata information while I'm injecting.
Yes.
I can add those on top of it, and I can get the real-time predictions.
Exactly.
Yeah.
Yes, exactly.
That can be achievable, which I see. But the demo which you showed, right? There is like one is like drag model, one is like function calling, which you have done, and that's context augmentation, which you are doing later one. But when you're giving this input, right? So NPC1 and NPC2, right?
Right.
You're doing a kind of like function, right? You write it, and how you doing the routing, right?
You're getting the routing. I also did that with WASM. So I write a small WASM. I look at which NPC is coming from. So if it's NPC1, I wrote it to NPC1 topic. So I'm just doing the routing internally. So I'm just hiding the small quick things inside it. Good call. I forgot to talk about it. Thank you. Any more questions? Yes.
I think the previous question somewhat covered it, but my question was, given that you are using WebAssembly functions to do the transformations, can you use the same functions to do rerouting as well?
Yes, we can do that.
Okay.
Yes, that's what I did. Yes, perfect. Thank you. Yes. It cannot be stateful. The reason why we made it fast is because we want to make sure, because when it comes to stateful, that means you have to store the state somewhere else, and it takes time, and we don't know how large the state is, so we don't tend to do that. So the purpose of these transformations is supposed to be fast and quick, and we see most of the the pipelines are mostly stateless, so that's why we built these. But for stateful, I think Rising Wave will be a better choice for those kind of things. Any more questions? You're welcome to come to me afterwards, and I've got stickers. Don't forget I have stickers for you. Right. Thank you.